Let's take a look at this identity. So I see two fractions on one side. I see two of the same trig functions on the other side. Not a lot we could do with the right side of the equation with what we know so far. So what we'll do is we have fractions on the left side. Let's see if getting a common denominator does anything. So my common denominator would be the product of those two. So this is the product of reciprocals. We'll come back to that, but you should be thinking about what is the product of reciprocals, which I think most of you already know. But let's see what we would put in the numerator if these were our two fractions and we have this common denominator. So look at the common denominator, look at the denominator of this fraction. You don't have a cosecant x, so say cosecant x times 1. That's cosecant x. And we have a minus. Look at this denominator. Look at the common denominator. You don't have a sine of x. So say sine of x times the numerator, which is 1. Alright, so this is the same thing as our numerator. But we have this stuff in the bottom. But remember, these are reciprocals. What happens when you multiply reciprocals? You always get 1. So sine times cosecant is equal to 1. If that's 1, it just goes away. So now I have the same thing on both sides. So I've verified the identity. Okay, let's take a look at this identity. Cosine theta cotangent theta over 1 minus sine theta minus 1 equals cosecant theta. Alright, so I definitely have a lot more going on the left side of this identity than I do the right side. So I see two terms over here. So we might want to get a common denominator eventually. I also see cosine times cotangent. And cotangent is cosine over sine, but I don't see how that would help me. It may. We may can come back to that. But to start off with, I really have no idea of where to go. So I just have to try something. Okay? The only thing I know that I can try for sure is I can get a common denominator and put these two terms together. Now just like if this was just 1/5 minus 1, the common denominator would be a 5, right? Because 1 doesn't have a denominator, or it's just 1. So the common denominator here would be just 1 minus sine theta. So for this first term, you just put cosine theta cotangent theta because it has the same denominator. Minus, this doesn't have a denominator. So you have to multiply this denominator, the common denominator, times that. So if we multiply this times, I guess you could think of it as a negative 1, then you're going to have minus 1 plus sine theta. Now it doesn't look like I've made this thing any easier. If anything, it looks like I've made it more complicated. Some of you would try to do this right here, but I don't suggest it. It doesn't really do anything there. Okay, so if what I've done so far doesn't make it any simpler or give you any direction to go in, then that may not have been the right way to start off the identity, and that's okay. If there's something else that maybe we could try, then maybe you would want to try that first. I can think of one other thing that maybe we could try. Alright, what if I did change everything in terms of sine and cosine? So then I would have cosine theta times cosine theta over sine theta over 1 minus sine theta minus 1 equals that. So this would allow me to do one thing that I know of. In the numerator here, now, what's cosine times cosine? Cosine squared. And that's over sine theta over 1 minus sine theta, and I have minus 1. So I see a lot of signs in here. I see a cosine squared, and the right side that we're trying to get to is cosecant, but we all know that's 1 over sine. So is there any way to change cosine squared into sine or sine squared? Yes. We all remember that Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So if I take and I get the cosine squared by itself, I have cosine squared theta equals 1 minus sine squared theta. So I could put that up here. Let's see. So 1 minus sine squared theta over sine theta over 1 minus sine theta minus 1. So I want to write this all as one fraction really quick. And the way that you do that is you take your denominator and act like it's over 1, the denominator of the bottom here. And so then you could do what? Flip and multiply. Now if I flip and multiply, this left side is going to become 1 minus sine squared theta over sine theta times 1 minus sine theta minus 1. Alright, now I don't want to just multiply this sign in, because if I did I would have sine minus sine squared, and that isn't an identity. However, if I looked up here at the top here, 1 minus sine squared theta, that is the difference of two squares. So what does that mean to me? That tells me that this numerator here will factor. I can factor that as one minus sine squared times 1 minus sine times 1 plus sine. And so that part factors. And so then what happens? If you factor this thing and you have a product in the numerator and a product in the denominator, the 1 minus sine thetas cancel out. And so we're left with 1 plus sine theta over sine theta minus 1. Now the next part you can do one of two ways. You can either get a common denominator and put these two terms together, or you can use term-wise division and break this fraction into its two pieces. If I broke this fraction into its two pieces, that would be 1 over sine theta plus sine theta over sine theta minus 1. And then we all know that sine divided by sine is 1. Anything divided by itself except 0 is always 1. Now I have a positive 1 and a negative 1, so they cancel out. And I'm left with 1 over sine theta equals, what's the right side? Cosecant theta. And that's right. So cosecant theta equals cosecant theta. And I'm done.